Assalamu alaikum. Triangles Construction Part 4. At the end of this period, students will be able to draw inscribed circles, draw perpendicular bisectors, and draw circumscribed circles. These are the materials we are going to use. Inscribed circle. Definition. The point of intersection of the three bisectors of the angles of a triangle is the center of a circle. This center is equidistant from the three sides of the triangle. The circle is called the inscribed circle and its center is called the incenter. Example. In order to draw the inscribed circle in a triangle, first we have to draw the bisector of each angle. It's a semi-line that cuts the angle into two equal angles. So here we have the bisector of angle B, angle C, and angle A. Their point of intersection is called the incenter. The incenter is the center of the inscribed circle. Now, to draw the radius of the circle, we have to make a perpendicular segment from the center, the point of intersection of the three bisectors, to one of the sides of this triangle. Here we have BC. Now we open the compass a length equal to this radius and we draw the inscribed circle. The three radii in this circle are as shown here. The center is equidistant from the sides of a triangle, that is, the distance from the center to all the sides of this triangle is the same since they are the radii of the circle, and we know that the radii of same circle are equal. Steps. D is the point of intersection of the three bisectors of the angles of triangle ABC. The radius of the circle C is obtained by drawing a perpendicular segment from D to one of the sides of ABC. C is the inscribed circle in the triangle ABC. Application. Given a triangle M and P such that MPN equal 40 degrees, M and P equal 50 degrees, and NP equals 6 centimeters. 1. Draw triangle M and P. 2. Find PMN, then deduce the nature of triangle M and P. 3. Draw the inscribed circle of triangle M and P. Please pause the video and try to solve this application. Solution. 1 is the figure to the right. 2, we have to find the third angle of this triangle. We subtract 40 degrees plus 50 degrees from 180 degrees. Since the sum of angles in any triangle is 180 degrees, we get 180 minus 90, 90 degrees. Then M and P is a right triangle at M. 3, we have to draw the inscribed circle. We draw the bisectors of the angles. 2 bisectors are sufficient to find the incenter. The incenter is the point of intersection of the bisectors, and at the same time it is the center of the inscribed circle. We draw a perpendicular segment from this center to one of the sides of this triangle. Here we have MN. We draw the inscribed circle about M and P. Remarkable lines, perpendicular bisector of a segment. Definition. A perpendicular bisector of a segment is a line perpendicular to a segment at its midpoint. Example. In order to draw the perpendicular bisector of each segment of a triangle, first we have to mark the midpoint of each side using a ruler. For example, AC is equal to 11 centimeters. 5.5 is half 11, so we mark the midpoint at 5.5 centimeter. E is the midpoint of AC. Using a set square, we draw a perpendicular line at E to AC, perpendicular to AC and passing through E. In the same way, we find the perpendicular bisector of AB, mark the midpoint. Using a set square, draw a perpendicular line passing through D. Also the same for BC. The point of intersection of the three perpendicular bisectors here is G. The three perpendicular bisectors meet at one point. As we see here, when we move the triangle, the point of intersection changes its place from inside the triangle to the outside of the triangle depending on the nature of this triangle. Steps: 1. Locate the midpoint of the segment. 2. Draw a perpendicular at that midpoint. As we see here, we have segment AB. The midpoint of AB is M. We draw a perpendicular passing through M. This perpendicular is the perpendicular bisector of AB. FA is equal to FB, MA is equal to MB, and PA is equal to PB. Any point on the perpendicular bisector of a segment is equidistant from its extremities. The three perpendicular bisectors meet at one point called circumcenter. The point of intersection of the three perpendicular bisectors is called the circumcenter. Circumscribed circle. Definition: the point of intersection of the three perpendicular bisectors, which is the circumcenter, of the sides of a triangle is the center of a circle passing through the three vertices of the triangle. This circle is called the circumscribed circle and its center is called the circumcenter. Example: we have to draw first the perpendicular bisector of each side. We mark their midpoints and we draw perpendicular lines passing through these midpoints. The point of intersection of the three perpendicular bisectors is the center of the circle. It is the circumcenter. Now we draw the circle. We need a radius to draw the circle. We draw any segment from the center to the vertices, to one of the vertices of this triangle. This segment will be the radius. Using a compass, we open at a length equal to the radius and we draw the circumscribed circle about this triangle. As we see here, the radii of this circle are the segments joining the center to the vertices of this triangle, and the circle passes through the three vertices of the triangle. J is the point of intersection of the three perpendicular bisectors of triangle ABC. The radius of the circle C is JB or JA or JC. We have here three radii. C is the circumscribed circle of triangle ABC. So here we have three cases. Acute triangle. In an acute triangle, the circumcenter is inside the triangle. In an obtuse triangle, the circumcenter is outside the triangle. And in a right triangle, the circumcenter is at the midpoint of the hypotenuse. Try to draw a right triangle and draw the circumscribed circle about this triangle, and you will notice that the midpoint of the hypotenuse will be the center of the circumscribed circle. Application: KML is a right triangle at K, such that KL equals 6 cm and KM equals 5 cm. 1. Draw triangle KML. 2. Draw the circumscribed circle about this triangle. 3. Where is the center of the circle located? Justify. Please pause the video and try to solve this application. Solution. This is the triangle. This is the circumscribed circle about this triangle. By drawing two perpendicular bisectors, we find the center of the circle, which is the intersection point of these perpendicular bisectors. Number 3, where is the center of the circle? We notice that the center of the circle is the midpoint of ML. What does ML represent for this triangle? It is the hypotenuse. So KML is a right triangle at K, and the circumcenter is at the midpoint of the hypotenuse ML. Assignment: review page 132 part 2 and 133 part 3b from the textbook. Homework: exercises 16 and 18. pages 136 and 137 from the textbook. Summary: kinds of triangles. We have isosceles, right isosceles, equilateral, right, acute, obtuse, and scalene. Remarkable lines in a triangle. We have the medians. Their point of intersection is the center of gravity. The heights. Their point of intersection is called the orthocenter. Bisectors. Their point of intersection is the incenter, which is the center of the inscribed circle. Perpendicular bisector. The point of intersection of the three perpendicular bisectors is called the circumcenter. It is the center of the circumscribed circle about any triangle. Construction. Triangle inequality. The sum of measure of any two sides is greater than third. Construct a triangle knowing the measures of the three sides. Side, side, side method. Construct a triangle knowing the measure of two sides and the angle included between the two sides. Side method. Construct a triangle knowing the measure of one side and the adjacent angles to this side. Side angle method. Thank you for your attention.